Hello. In this lecture, we are going to learn about the internal architecture of 8086 microprocessor. So, before getting into the topic, let's clear some basic which we have covered in the previous lectures. What does a microprocessor do? The main three work of a microprocessor is to fetch an instruction or a command, decode it, and execute it. Okay. And where is a microprocessor? Microprocessor is basically inside a CPU. The CPU takes input or output from the I/O port. I/O port is in like USB port, mouse, keyboard, speaker, microphone. All those are, you can consider them as I/O devices, and there are ports assigned for each device. Then CPU also or the microprocessor which is inside the CPU takes instruction or the command from the memory. Okay, this is called fetching. The CPU or microprocessor inside the CPU takes the command or instruction or what next to do from the memory is called the fetch. Microprocessor fetch the instruction from the memory and execute it accordingly. So in this lecture, we are going to be focusing on the fetch, how a microprocessor fetch instruction or command from the memory. Okay, I hope this part is clear. So let's move on to the next part. This is a picture of internal architecture of 8086 microprocessor. Pretty complex. We will break down each part and I hope you will understand it easily. So there are two major parts in this internal architecture. One is BIU or bus interface unit. The other is EU or execution unit. For simplicity, we have to learn BIU first. Then we will learn each part, what does it do, and then we will combine all this to see how a microprocessor works. This is basically the inside of a microprocessor. This is basically the inside of a microprocessor. Okay, so first of all, let's see what are these. What is this section in the BIU or bus interface unit? These are stack segment. What is the stack segment? I will get to there. First, let's see what these names stand for. ES stand for extra segment, CS stands for code segment, SS stands for stack segment, DS stands for data segment. DS stands for data segment, and one pointer register is IP or index pointer. Now, what is register? All these five are registers. What is a register? Register is basically the combination of flip-flops. Now, what is flip-flop? A flip-flop is basically a circuit or device which store a single bit, 0 or 1. Basically, register stores a ton of bits in binary format, of course. Now, these five are registers. The first four, ES, CS, SS, DS, are stack register, stack segment register, or we call them segment register. Why we call them segment register? We will get to that. Okay, so first four is segment register. The last one, IP, is a pointer register. I hope the name was clear. I will recall them one more time for you. ES is extra segment, CS is code segment, SS is stack segment, DS is data segment, and IP is index pointer. These are five registers. Now, as we have said that we are going to focus on the fetch, how a CPU fetch instruction. Now, first of all, we have to know where is the instruction. So, every instruction, what the computer needs to do is written in the memory, the main memory, RAM. Okay. So, this BIU is responsible for fetching the instruction from the memory. And these five registers are also responsible in the fetching process. Now, something about memory you need to know before getting into it. That memory is divided. In this architecture, memory is divided into four parts: code, data, stack, and extra segment. The memory is divided into four parts. Let me show you. So this is basically the memory. There are code segment, there is data segment, there is text segment, and there is extra segment. These are the 4 segments in the memory. These are not the register. The register is in the CPU. These are the registers, and these are the segments in memory. Their name is same, but there is a reason why the name are same. Uh, we will tell you about that. But this is the segments in memory, and these are the registers in CPU. Let's combine them. In this picture, we can see that here are the registers CS, DS, SS, ES. CS, DS, SS, ES. These are the registers, and they are assigned to each of the segment in the memory. CS is assigned to code segment in the memory. DS is assigned to data segment of the memory. SS is assigned to stack segment of the memory, and ES is assigned to extra segment of the memory. What do I mean by assigned? Basically, how a CPU will know where to search the next instruction in the memory. The CPU will never know that, right? So we have to some mechanism, have to give some mechanism to the CPU so that it understands how to fetch the next instruction. So the architecture says this: the instructions are stored in this code segment. So what will the CPU do to fetch the next instruction? This CS is a register, and there is a address stored in this segment register. In this code segment register, there is an address stored. Now, if you clever enough, you will understand what address it stores. It basically stores the memory address of code segment. Basically not the memory address, actually basically the base address of the code segment. Now what is a base address? This is the fun part. The base address is basically this straight line you see. The base address indicate this, we have to go to the code segment. Now this straight line or this base address indicates that we have to go to the data segment. This straight line or this uh, SS stack register indicate that we have to go to the stack segment. This straight line indicates that we have to go to the extra segment and pointed by ES or extra segment register. So these 4: code segment register, data segment register, stack segment register, ES segment register stores the address. What address? The address that tells us to go to this segment of the memory. The code segment register tells us to go to the code segment of the memory. The data segment register tells us to go to the data segment of the memory. The stack segment register tells us to go to the stack segment memory, and the extra segment register tells us to go to the extra segment of the memory. Now, is this the address of our next instruction? No. Here is another register left, which is IP or index pointer. So this is like the page number of a chapter. Let me give you an example to understand what is going to happen next. Suppose you know there are 4 chapters in the book. You want to read the you want to read a line in this book. You know that line is in the first chapter, and 75 number page, the page number 75, first chapter, page number 75. So what information you need to find that line? First of all, which chapter? Second of all, in which page? So by the code segment register, we know that we have to find the next instruction in the code segment of the memory. But where? The code segment is not just a one place, it's a block. There are many addresses, many information stored here. So where we find the next instruction? So this is basically the IP's work or index pointer work. So index pointer tells us that go by 75 page down and you will find the next instruction. So basically it's like the book, the chapter 1 and 75 number page. So code segment register tells us that we have to go to the code segment. Where is the code segment in the memory? Basically it tells us the address, and the IP tells us that in the code segment, in go that place and you will find the next instruction. So basically CS or code segment register plus IP or index pointer is equal to the address of the your next instruction, which is fetched by the memory interface. One more thing, this is an arithmetic function. This does ALU. Basically, this is an ALU. You will say this is ALU. Well, this does many things as add, subtract, divide. This also does add, subtract, divide. Why you need an add function, add circuit in here? Because we want to add CS plus IP. This gives us the address of next instruction in the memory which we are going to fetch. So this is how we are going to fetch the next instruction.